Okay, so yesterday, yes, we talked about uh, Numpy. We introduced the Numpy library for working with multidimensional arrays, so tensors, in a very convenient way. Um, and we more or less stopped here. Uh, and we said that, first of all, one of the first use cases, let's say, to prefer NumPy arrays than Python standard lists is that, or even pandas series, is that with a NumPy array you can represent any multidimensional array, so any tensor, whatever the size, and you have, besides a more efficient way of computing things, you also have some quality of life, let's say, improvement. For instance, we commented yesterday that with a plain Python list, you cannot have immediate access to columns if you create a list of lists to represent a matrix, for instance. Instead, in NumPy you can. And the second big use case is about operator spreading. So the same mechanism that we have seen for series and pandas data frames, in which you can immediately apply an operation to the whole tensor instead of without having to iterate element by element the tensor. So here, for instance, we can make a few examples. We can also apply the operator to a portion of the array. So we can first slice our data structure, as we already seen in the indexing slides, and then apply the operation only to that portion of the tensor. And for instance, let's try to do this in practice. Not here, but here. Let's call it operator spreading. That should be the name I used in pandas. That's more or less the same. So if I have a new, let me import NumPy. If I have a, let's say a matrix or whatever, let's wait for it to start. As I said, the first time is a bit slower. So if I want an array of zeros, and the size should be, I don't remember if this is the correct way to specify the size. Yes, so this is our multidimensional array. In this case it is a matrix. It is only zeros. So if we want to apply any operation, let's say we want another version in which each element is plus 10, we can simply rely on the mathematical symbols, and the operation will get spread to all the elements. And this obviously works without constants, but with operations among tensors. So if I do this, vector v is the pointwise summation. Okay, so we have y is x plus 10, so y should be all 11s, and v is x plus y, so all 12s. So this is again a convenient thing that we cannot do with lists. We cannot use this operator with lists. Keep in mind that for pandas, for series and for data frames, we have seen that we can use mathematical operators right away, but we have also seen that this can lead to problems in case of missing values. And in that case, we have seen that a way to remedy those problems is to not use the symbolic operators, but to use explicit functions that are provided by pandas. In this case, we don't have this problem because we don't have the issue of missing values. However, you should also keep in mind another thing. Let's do something like this. Let's do this. Let's create at random 1, 0, 10 elements. Another random. Okay. So these are our arrays. Let's do X and Y. Shouldn't this be 10 elements? Y array 0, 0, 10. Size, maybe. No. So this, no, that's the step. That's the step, right? So we need to do another thing to create many elements. That is, we don't have in this case. We have the step. So let's try another way. Let's do this. Not zeros, but here. Okay, this is fine. This should be fine. Step is 1, so now we should have 10 elements. Okay, wonderful. So if we now reshape the arrays in a meaningful way, so let's try to do reshaping. Let's try to do this way. And then we can also reshape Y. This is not really easy to see. Okay, so we created 2 arrays. We give them a shape. Okay, with the reshape we can actually reshape, so change the kind of tensor we have. So first we had 2 one-dimensional tensors. Now we have 2 b-dimensional tensors, so matrix. One is 2 rows, 5 columns. The other is 2 columns, 5 rows. If we want to add them, let's try. There's a problem. Okay, why there's a problem? Because with respect to the plus operator, the two matrices are not compatible. Okay. And the same happens for the multiplication, for instance. Okay, so you must make sure that your tensors are compatible. Now, if we reshape one of the 2 arrays to have the same dimensions as the other, the broadcasting of the operator multiplication can be done. And obviously, the same happens for the summation. Okay, so this is one thing that you must pay attention. Operator spreading does not work by magic. It is simply that the same operation behind the scenes is applied element-wise. But obviously you must have compatible shapes between your two arrays. Okay? So again, if we reshape this like this, won't work because the dimensions of the two tensors are not compatible for operator spreading. Operator spreading supports element-wise calculations. Okay? If you want to do like algebra calculation, matrix multiplications, transpositions, whatever, you have other methods to do so. Then it may be convenient to either load the data into Numpy tensors or save Numpy tensors to a file for later processing. I mentioned this in the slides, but honestly, I don't think this is a good way to save this kind of information unless you need it for some technical reason, simply because the file is not really human readable. So anyway, you can choose two formats for saving Numpy tensors. One is a binary format and one is a textual format. Binary format means that a specific file extension is created that is meant not to make the contents of the file available and understandable by a human reader, but the goal is to make the file as smaller as possible. Okay. The textual format, instead, on the contrary, I think it creates a simple txt file, is instead meant to be read by a human, assuming that you can read a tensor from a file. Nothing special here, it's very easy. If you want the file in a textual format, just use the save text method, and the delimiter and the formatting string are a way to choose how the tensor should be represented in the file. So formatting means, for instance, I may want to only store 2 decimal places. Okay, so I can use the fmt keyword to specify a formatting string, similar to the kind of formatting string we have seen for datetime objects. You can find more of this in the Python documentation. And the delimiter instead is the default delimiter between different elements of the tensor. The default is I think that the default may be empty, we can check, but anyway you can specify a delimiter here. So let's try to save these files. Input, output from file. And so here we can create a huge, let's say, tensor. Let's do it like, and then we can reshape it. Be fine with this. No, because I started from 1. Okay, so in this case is a tensor with 3 dimensions. Okay, so it is basically a list of matrices. Each matrix has 10 rows and 100 columns. That should be correct. And we can now save it to a file like this. Save, so np save txt, and we have the name of the file, we can simply array .txt. We don't want any specific formatting, we don't want any specific delimiter, we just want to check how the file looks like. So let's we didn't tell it what to save. That's weird. It says that it can only save it should save any arbitrary format. Anyway, I will check this, but let's reshape our file for now, our array for now. So let's do something like this. Yes, this is a matrix. Where is it? Okay. Then let me take a note. Check 3 plus dim. And if you save something in the collab, the file gets actually saved in the same place. Let's say you have this sort of navigation menu on your left. This is the same place where, if you remember, we uploaded our datasets. And as happened with our datasets that are no longer available, as soon as you shut down this collaboratory, your file is gone. Okay, so that's okay for this kind of tests. And we can try to open the file and see what's inside, and you can actually see what is the default formatting. So for instance, the default formatting we learn now, I forgot actually, that it is a scientific notation. So that's the default formatting for the values, the numerical values of the tensor, and the default delimiter is a blank space actually. So you have no comma. We can obviously try to modify this by basically repeating the command, but using the optional arguments. I never remember those, but I think that this should give us a two decimal places. Maybe we can check. And the delimiter, we can put, for instance, a comma. Let's see if it works. Let's see what the output is. No, I did something wrong. Maybe it was this. I never remember how to do that. No, I don't think so. So let's keep it like this, that I know it works. So this time instead we changed the layout, basically the representation of our numbers, of our vectors. Now we have only the integer part of the number, not in scientific notation, and we have a comma separating all the values. And since this is a bidimensional tensor, we have a one-to-one mapping with a matrix representation. So each row in the file is a row in the matrix, each column in the file, which is identified by the commas, each column in the file is again a column in the matrix. Obviously we can read the file back. This is a quick reference for the formatting specification. So if you put a C is a character, D or I are integers, E is the scientific notation, but that's the default, F will be a floating number, and whatever. Obviously you can read back data that you saved to a file. Keep in mind that while reading, there should be load command load txt, let's assume the first argument is the file name. Remember that if you change the formatting, you need to take care of the changed formatting when you read back the file. Okay, so since we changed the default formatting, we cannot read the file as is, because Numpy tells us, I don't know what this is. Instead, if we kept the default formatting like this, so this is the default formatting, scientific notations, values separated by a blank space, we can read it back with no problem. Okay, so keep in mind you have to change the format even when you read the file back. Then there is another way I mentioned to save files that is meant not to be read by a human. It is just meant to save the file in the quickest way and with the smallest space of occupation possible. So if we instead use something like np save the or save the compressed, okay, usually when you want to save a file in this way, you want a compressed file because you want to save space, you don't care about humans reading your stuff. The extension is npv, if I remember correctly. Yes. Where are here? And we don't mess around with the formatting, whatever, but we can check what happens to the file. So new file, okay, appeared finally, and if you try to open the file, there's we get this basically. Whenever you open a file and you get this sort of gibberish, I don't know if it happened to you before, it means that the file has been saved not with an encoding which is compatible with textual data. Okay, sometimes it happens. For instance, if you try to open, if it never happened to you, just try to open an image with a text editor and that's what happens. Okay, the file has been encoded in a way that is not interpretable by a text editor that understands some encodings like UTF-8, Unicode, whatever. So we cannot actually see this file, but if we save it in this way, we don't care. That's the catch. So if we save the file this way, we don't care. We only care about being able to load the file back. So with load instead of load text, we can read back our file and get back our data. Okay? This probably gives you the file. Load arrays, file, let me check, file like, blah blah blah, blah blah blah, blah blah blah, I don't care. Returns data stored in the file. For MPC file, the return distance must be close to the file descriptor. We don't care. How can I expect it to have the class xarray npz. What if we have dot? I need to check this. Npload. In this case we have two data, probably this way. It seems weird to me, but maybe no, and I suspect that neither this. No, I need to check how to access actually the data. Npload probably doesn't work anymore as it used to be, because this time you only get a reference with the object. Yes, So I need to check this. And again, this is for having a file that is smaller. Let me check if we can. No, I don't think we can see the size of the file from here, but anyway, it's a smaller file because it has been compressed. I doubt you will find yourself often saving a raw NumPy array on a file. As we said, the main use case for using NumPy for you in the context of this course will be for technical compatibility with some algorithm, and in that case probably the library that gives you, if you want to, I don't know, save the state of a neural network, probably the library that you're using gives you method to save the neural networks. You don't have to extract the weights of the neural networks in a NumPy tensor and save those. So this is just for the sake of completeness, but I don't think you will make much use of this sort of stuff. It is usually preferred to, even if you have something to save, to transform it into a pandas data frame or a series and save the data frame or the series. And at last, the last library that I told you anticipated I will just mention is SciPy. Not because it is, I mean, less useful than the other libraries. It's simply that it happens to be less pervasive in this course than the others. So while I am sure that mostly whatever projects you want to do in this part of the course you will probably use pandas like 90% or 99%, I'm not sure that you will need to use SciPy. I'm not sure you will need to use NumPy. NumPy is far more probable. This SciPy library is strictly connected to NumPy, so basically the data structure that is assumed that you are working with when you work with SciPy is an ND array, so they are strictly connected. But as I said, NumPy is mostly about numerical manipulation and efficient numerical manipulation on tensors. Instead, SciPy has lots of functionality for different goals: linear algebra, optimization, statistics, even signal processing. Okay, these are simply a few modules, an excerpt of the modules you may want to take a look at depending on your interest on your project. So for us, for instance, optimization could be, or statistics probably, if you want, for instance, to compute some statistics out of a data set, out of a prediction model. Obviously, all of these kinds of libraries have been developed mostly separately. Okay, so SciPy, NumPy, Pandas, the libraries that we have seen, that we have used for machine learning like scikit-learn and PyTorch have been developed separately. So, for instance, it is highly likely that the kind of statistics you need, for instance, to check the performance of your predictor, is already included in scikit-learn. And it is also highly probable that behind the scenes scikit-learn uses SciPy stuff. Okay, so that's quite common in programming. You try to avoid reinventing the wheel as much as possible. So if that's a good library for doing something, other libraries build on top of that one. But anyway, this is a kind of library that you may wish to use for all of this sort of stuff. And as you can see, there are lots of modules that are specialized for different things. So to some extent, NumPy instead is much more focused. You only care about numerical manipulation of tensors, that is. You don't have many modules in NumPy, you don't need them. So, for instance, one that could be relevant for us is the SciPy stats module, because, for instance, this gives you access to probability distribution. So a uniform distribution, you can quickly compute Pearson correlation coefficient. I think we had this sort of stuff in one of the earliest examples. So these kind of statistical measures you can easily have with SciPy stats module, calculating the percentile of a given distribution, Okay, these are just random examples, okay, of the things you can do. You can have some sort of hypothesis testing. Chi-square is, I would say, pretty standard method to check the relationship between two distributions, okay? So it's usually a good way to do hypothesis testing. So let's say that I have some expectation about whatever, I observe this. What is the difference? How meaningful is the difference? Can I say that it is just due to random effects in measurements, or there is something going on here, okay? So again, we don't look really into this library, because most of the things that we use into this course and into our examples have been already built into other libraries like scikit-learn. I don't remember actually, but I think that the performance functions that you have in performance measurement functions that you have in scikit-learn are actually implemented on top of SciPy. I'm not sure, but it could easily be. So again, the purpose of these slides was to give you a quick, and I know that this can be a bit confusing, but a quick overview about Python and the kind of libraries that are useful and relevant for the contents of this part of the course. And as I said, if you need some assistance in programming, don't be shy and just send me an email. I think I already said so, but for developing your project, you can take inspiration from projects that you find online. If I remember well, I already mentioned this platform, Kaggle, which is quite famous. I think you need to register to access dataset or whatever, but the registration is free, and they don't spam you, they don't bother you. Here you can find many things. You can find datasets, and the good thing is that based on these datasets you can even find, for instance, tutorials that explain you how to do something with the dataset. So I'm well aware that by giving you this kind of references can be dangerous, but I also know that you will find them anyway. So for the project of the course, it is perfectly fine if you look at one of these projects, take the projects, modify the project, okay, to do something else. You change the kind of predictor you will be using, you change the kind of performance metrics you will be assessing, you compare 2 or 3 predictors, and in the original tutorial it was not done, or you simply grab a dataset, okay, that's perfectly fine. When you propose the project, just be transparent, okay? I wanted to do this project based on this dataset. I found this tutorial that I plan to get inspiration from, and I will change these things. That's fine, okay? It is also fine, and then I will issue a warning. It is also fine for me to use code assistants, okay? Like Copilots or ChatGPT or whatever. Beware that they can do mistakes. Okay, so is it fine if you use code assistants for doing something? For instance, okay, I'm trying to plotting this kind of scatter plot, and my integrated development environment suggests me a way to do that. Should I accept the suggestion? Well, try, see if you get what you want, but do 2 things. First thing, see if you get what you want. So check what the output of the suggestion is. Second, if the code that is suggested to you is something you don't know, try to look for what it's doing, okay? So it is a method that I don't know from the scikit-learn library. Go to the scikit-learn library documentation and read the documentation of the methods to check what it does, okay? To me, that's perfectly fine. But obviously, during the oral exam, I expect that if I ask a question about a specific function in your code, you will be aware of what the function does. So don't be unprepared in this in this sense. So again, getting inspiration from whatever, not only Kaggle, but from GitHub repositories, for whatever is fine. Just be transparent if you're in your first mail about the project. That's perfectly fine. So now, I think if you agree, we can skip the pause and maybe finish a bit earlier. Now I would say that if you have some specific questions on the products, this could be a good way, a good moment to have a chat about that. Or we can try to look at this exercise, this few exercises that I borrowed from my colleague from last year. These few exercises that you find in the at the bottom of the slides of the course. First of all, what's the purpose of this exercise? Let's clarify one thing. It is not that during the oral exam I can ask you to do an exercise similar like to this one. That's not the case. Okay, so don't be scared. In the oral exam, I can ask some quick questions about your project. So what if I want to change the metrics for doing model validation, model scoring? And I expect that you can maybe not exactly write the right line of code, but that you have an idea of what to do. Okay, that's the expectation, but not to do something like this. This is just to give you some exercise, okay, to check whether you are more or less comfortable in doing this sort of, in using this sort of libraries. So, for instance, if I ask you based on a dataset, okay, this is Boston Housing dataset, is a famous dataset about the price of houses, average price of houses in different neighborhoods and suburbs of Boston. If I ask something like, if you want to explore this dataset and quickly check whether a few attributes have some sort of correlation, how would you do? Okay, that could be a question. And I expect that you know that, well, the most easy way to do so is to plot some scatter plots. Two variables, okay, pick two features, draw a scatter plot of the two features, and you can find some meaningful pattern. For instance, if the points more or less align into a line, there's a linear relationship, okay, a linear relationship between the two variables. So that's the kind of things I expect. I don't care if you don't exactly remember how the scatter plot method has to be used. I don't care. As you have seen in my lectures, I always forgot something about how a method works or whatever, and I need to look it up. It happens. So I don't care. What I care is, you know that the scatter plot is the appropriate thing. You know that you can rely on the matplotlib, and at least maybe try to remember more or less how the command looks like. But I don't really care about that. Okay, I care more about, given a question, you know what are the tools that can answer that question. So these exercises are to be interpreted in this way. Okay. For instance, second question in this first exercise. Build a regression model that aims to predict the housing price, and I give you some hints. So first, only use LStat, which is one of the attributes in the dataset. So one regression model to predict a target variable using only one feature, then using two features, then trying to use the whole data frame. I want you to split the training and testing set in this, and to compute this kind of error on the test set. Okay, so given this instruction, okay, what do I expect? Well, I expect that, first of all, that you know what kind of regression models you could use. Okay, because it depends. For instance, if the variable in this case is a numerical variable, we can do linear regression. We can do regression with a neural network. Okay, we have a few ways. We can even do regression with, we mentioned it with decision trees if you want. Maybe we don't have an example. So, with support vector machines. So, first of all, I expect that you know that there are a few ways in which you can do the regression. Then I expect that you do know why, for instance, I'm asking you to split in training and testing, and why I'm asking you to fit the model on the training set and computing this measure on the test set. I could ask why we are not computing this on the training set. I expect that you know why. I expect that you know what this is. And then that's it. I mean, if you don't exactly remember the specific instructions, I don't really care. Okay? But again, these exercises are a good way to check whether you have some sort of, at least, proficiency. Okay, so if you have no idea where to start, okay, probably you need to look a bit better into also the code examples. If you more or less know where to put your hand, but are just missing some details, for instance, I don't remember exactly, I don't know, I don't remember exactly what the specific function arguments are, okay, fine, that's not a problem. I don't remember exactly the order in which these portions of the dataset are returned. I don't care, okay, that's the kind of stuff. And so here you have these few exercises, roughly, maybe in order of difficulty. I mean, I ask few things on the first exercise, maybe a few more things on the second. So in the second exercise, you have some crabs, okay? A data set about crabs. Blue-orange crabs, a set of features like the length, the size of the lobe, and stuff like that. When it is not clear, I try to quickly give you all the information relevant. For instance, SP is the target column that we want to care. And then I ask you to build a decision tree. Okay, classify the target that I said, plot the tree and the confusion matrix, and show with some kind of plot that some attributes are highly informative. Use the decision tree. What actually does it mean? Well, there are a few ways in which you can show if an attribute is important to make the prediction, okay? Why I said I wrote here use the decision tree? Well, you should know that the decision tree gives you an idea of how important is that feature to predict the target. It is the Gini index, the information gain ratio, no? When we started the decision trees, the decision tree algorithms try to maximize, no, the discriminatory power of the feature. So, one approach here will be, look at the decision tree. We know how to actually plot, visualize the decision tree, even both in text and in a graphics way with a graph. Look at the attributes, okay, when you do the first splits. Usually, those are the most important attributes, okay? And then, how you can show how an attribute is important. Well, one quite easy thing to do, let's check first if that's what I did. Where is it? This is the decision tree. Prediction, classification report. Okay, I didn't put it, so maybe I will add, but one simple way is the way we used in the first exercise actually. Just plot the feature that the decision tree told you it's relevant on the x-axis and the prediction target on the y-axis. If you find that they are more or less correlated, yeah, you have a confirmation that they are indeed, that the feature is indeed important. Another alternative, what could be? could be computing the Pearson correlation coefficient. Okay, take the two values, the prediction target, the prediction feature, and compute the Pearson correlation coefficient. We have seen many ways to compute the correlation between two variables. Okay, so that's another way. If the coefficient is high, the two variables are highly related. Since one variable is the target and one is the feature, I can safely say that that feature is highly informative for the target. Okay, these are the kind of stuff that I care mostly about. That you can understand how to apply the tools we mentioned to specific problems. Actually applying them via coding is not necessarily the focus of the exam. Exercise 3, I tell you, is much more about pandas manipulation. Okay. If you find yourself in the future in a job position, or if you want to do research and whatever, and you find yourself doing data analysis, you will find yourself spending much time with pandas. Okay, so this is more of an exercise about pandas. So I can ask you something. This is a data set about flights schedules in New York, I think. Yeah, New York airports. And I ask you things like, is there any record of a delay of over 2 hours? And in the dataset you have this information, so it's not something that you need to calculate in difficult ways by using date times. No, it's almost all of this is already ready in the dataset. Find the flights that flew to Houston. Okay, if you think at all of this kind of stuff, it may be very similar to the kind of exercises you did, if you did, when you had a course about relational database. That's the kind of stuff you usually do. Filter this data, aggregate that other data, check this other thing. Okay, so find all the flights that departed in summer, arrived 2 hours late but didn't leave late. All this information is already in the dots. And then I ask you some plot. The number of flights per carrier, so the company that owns the flight, some grouping, the correlation between the delay at departure and the delay at arrival. Okay, this sort of stuff. And here basically the whole first part is just doing queries. That's why I said it's, if you had a class about databases, that kind of exercise should remind you of that class. And the second part is about instead visualizing. Okay, grouping, visualization. And then there is the last exercise, which is more or less the more comprehensive. I ask him for some plot, then I ask him for learning a decision tree, and also here you do have the possible solution. Okay, keep in mind, in programming that's always the case. The solution that I give you may not be the only solution. Okay, it may be the solution that I find to be easier to understand. Maybe it's not the most optimized. Okay, it may be for many reasons I could decide to put one specific solution, but keep in mind that it's not the only one, usually. Obviously in this exercise they are quite precise, so if I ask you for a column in a pandas dataset, there are not so many ways to get a column from a pandas dataset, but in general the solution may differ. If you have any problem in accessing the databases or with the solutions, just write me an email and I will check. Or if you come up with different solutions, if you have no clue how to do something, you Google it, or you ask ChatGPT and you have no clue about the solution, write to me an email. Okay, I know that I'm getting bored, but but I always tell this also with my first year students. Maybe since they are first year they are more shy, but don't be shy. Send me emails. Okay, the worst that can happen is that I don't reply for a few days. That's the worst that can happen. Okay, I will not get mad at you because you sent me 4 emails. Okay, so write me emails if you need some sort of assistance. So are there any questions about the project? For instance, do you already have an idea? There is something unclear regarding the specification of the project? So the project should be described by a PDF in the website. So here, okay, what's written here is one source of information, and then I put in the forums, I think, some more information, exam clarification, for instance. Okay, there should be all of the information, I think, about the exam that includes the project. But if you find that something is missing or something is not clear, tell me. Okay. But anyway, here there should be all the information that you need. Here you have the PDF, which describes the general rules, some exemplary projects, some places where to get data or suggestions. Okay, so anyway, if something is unclear, just write to me and I will try to be as clear as possible. So are there any questions? Yes?
I wanted to ask,
Okay.
just to have an idea of am I overdoing it? Am I?
Yeah. Okay, so the question, just for I repeat for the recording because I don't know if it will be captured. The question is about the size of the project. The project should be small, and small doesn't mean anything. So the project should be nothing too much different from our own examples. Okay, so keep in mind that, let's do this. So this is the support vector machine applied to this kind of sonar stuff. Okay, these are 50 lines of codes. Obviously these are examples, so they are just meant to showcase the method that you want to use. So let's assume that you do a similar thing. So you want to do some sort of support vector machine prediction based on a different dataset. Okay, so maybe you will have some more pre-processing, let's say 20 lines of pre-processing, and then you want to compare a few models. So you don't want to stick with SVMs, you want to compare SVM, decision tree, and another regressor, 3 regressors. Well, you can go to 100 lines of code. I don't expect 1,000 lines of code unless you are interested for your own stuff. Okay, it is obvious that if you come to me with 1,000 lines of code, I will check the 1,000 lines of code, and that's fine. But that's only if you are interested, if you plan to do some thesis, internship. There is another exam in which you can reuse the material. I mean, otherwise, the size of the project is something that should be comparable to the size of our examples. So, for instance, obviously, when we had the example of, where was the example? The multi-layer perception with PyTorch, that was the biggest one, I think. I don't remember exactly, but I think this is the biggest one. But this is the biggest one, and it was done on purpose, okay? I explicitly said, look, this is only for those of you who want to go deeper into neural networks and want to create their own neural networks and also their own learning process. Otherwise, you don't need it. Just use scalar, another 40 lines of code. Okay, so the project should be something compared. So there is not really, obviously, doing something meaningful with 30 lines of code could be not enough, okay? Because with 30 lines of code, what could you do? You could do some visualization and maybe one training. No, you can't do too much, okay, with that line budget. But don't imagine the project to be extremely bigger than our examples. If you simply, for instance, what we did here, we plotted the decision tree, then a random forest, then gradient boosting, and we got to 63 lines. Okay, so it's not, I mean, it is obviously difficult to give you some range, but if you wish, let's say above 50 lines, below 300s. Let's put it this way, okay? Just as a rule of thumb. But again, another thing I want to emphasize is you don't need to contact me only to propose the project, and if you have the green light, only at the end. You can contact me in between. Look, I got to this point. To me is enough. I worked on this for 2 weeks. So in my opinion is enough. Do you agree? Yes or no? And if it's no, I will suggest something to add. No, maybe this is a bit trivial. Try to add these kind of things. Try to do some more visualization, okay? Stuff like that. And the project can vary on all the topics. So you don't need to do learning. You can do a project only about visualization. Okay, compare different way of visualizing things, or do some interactive plot in a very fancy way. So it is not that you must use use learning for mandatory. But yeah, anyway, the golden rule is, if you are in doubt, just send me an email. Probably if you have the impression of doing too much, you are doing too much. I learned from the experience that usually if you have the impression that you are doing too much, you are right, you are doing too much. So in that case, check with me. Association rule mining is something that we looked a bit into, and one may want to expand. Don't be afraid of. This topic is interesting for me, but we only mentioned it with the professor, so I don't really know what the library allows me to do. Don't be afraid. Go to the documentation. All the libraries that we used in this course have been chosen because they have very good documentation, because they have lots of people working with those library, and even beyond that documentation, you can find lots of tutorials on the web. So I got fascinated by this rule mining, so I want to know more. Go to the library website, MLXten, find some tutorial, and propose a project inspired to a tutorial when you try to do something different. That's fine. So don't be afraid to expand your knowledge beyond what you have seen in the course. Because again, the main goal of the course was to give you the knowledge of the tools that you can use. Okay, so you must know that exists a thing that is called decision tree and that works well in that field. You must know that there is a scatter plot that is different from a box plot. Then obviously, in the space of what the whole course is, 12 credits, right? So a half is 6 credits. We cannot overview all the libraries in detail. So that's fine. Go and check it, and check the libraries on your own. You will find plenty of documentation, plenty of people that has your exact same problem on Stack Overflow. So, and again, you can write me emails if you get stuck somehow. Last bit, then if there are other questions, for the kind of work that usually you need to do, the only part of the course contents that may be a bit trickier than others is the reinforcement learning part. That's because usually it requires you some stuff to get ready. you need to use a library to simulate the environment, you need to use another library to check, to take the algorithm, or you need to implement the algorithm. It is not something impossible, okay? It's simply, that could be something that on average requires you a bit more work than the rest of the arguments, of the topics. That could be. Any other question about the project or whatever aspect of the SM or the course?
Professor, when we are as a part of project, same data set, and we want to develop a model which is giving best accuracy. So if we present that as a project, what could be the metrics that you would consider as a for the model evaluation? Is it only accuracy or precision or something else?
It's up to you. So I repeat the question again for the recording. The question was, let's assume that we choose a project in which we want to improve as best as possible the performance of a given predictor, a given model. What are the metrics to assess the model? You choose the metrics to assess the model. So you can say, for any reason, I want the best possible model according to accuracy, according to precision, according to F1, according to both, trying to optimize both. That part of the thing is up to you. So you decide, and whatever reason is fine. We have seen that there may be scenarios in which precision may be more relevant than recall, for instance, or other scenarios in which instead recall does matter more. So that's up to you. The question may also imply another thing, a related thing. How do I evaluate whether you optimized the model enough? Well, I mean, if the project is about optimizing the performance of a model, don't come here with a model that has 60% performance, okay? That's marginally above random chance. But I don't care if it's 99% of accuracy or 91. It's fine. What I care about more is show me your process of getting there. Do not show me the final model. Show me the first that performed badly, extremely badly. Then show me what you did to improve. Then show me what you did. That's what I care about, not the final. If the final is 80 accuracy, that's fine. I want to know the reasoning, okay, you did to improve the model. Yeah?
Do we have to prepare an essay for this?
No, not necessary. It is not necessary. If it's, do I mention an essay in the? No, I don't think so. The project has no grade. Bring along your project. The discussion starts from there. Let me check. Choose truths to the topics, a discussion. Brief report. It is mentioned. Yeah. No. I don't really care. At most 3 pages. Well, yeah, it could help you. I mean, if you want, bring some slides or a brief report. It could help you to articulate what you did in the project, that kind of stuff. But honestly, it is not really necessary. Bring your project and be ready to discuss your project. But yeah, maybe a small report, a brief report, or a few slides could help you more than me. Okay, it is not required, but if it helps you, yes, you can. As I was saying, for instance, it may help you in keeping track of what you did, the kind of reasoning you did. Yeah, bring along an essay, it's fine. Yeah. And the last bit, but I think it was written. Maybe in the slides, or maybe I left it off. Please give us some time to check the project. Even if the projects are small, do not book your exam on January 9th and deliver the project the day before. Okay, give us 2-3 days, more or less. Okay, so that we are sure that we can check the project in time for your exam. Okay, so just pick a date when you want to give your exam with me or with Professor Monica, and then submit the projects a few days before. A week may be too much, but 2-3 days give us enough time to check the project if we have other duties in those days.
So, Professor, like if, for example,
Yeah.
DS on mid of January somewhere, or January 21, something like that. So when should I complete my project and share you the email? If my project is related to data science, even though I'm giving AI on 9th, should I complete it before 5th or something like that?
You should complete your project before doing the exam.
Before
Yeah.
the first exam?
Yeah. If you want to do the exam on the, what is the other day, 21st of January, I think, you don't need to deliver the project before January 9. You just need to deliver the project a few days before January 21st. So it depends on the exam date you pick. I don't remember actually. 9th of January, 21st of January, and 14th February. No, 11th February. So depending on the date, okay, you have more time to do the project.
But I have an exam for artificial intelligence on January 9th.
Yeah, I know that date we have both exams. In that case, for even if the project is on my part, you should bring anyway to that part of the exam. There are no limits on the number of people that can register for an exam. You are not a huge class, so I don't expect this to happen, but if there are too many people for one day, we can maybe arrange for the day after, but honestly, I don't think it will happen. I think all the exams will be ended in half a day. Why the registration is mandatory and actually has a deadline? You should register a few days before the actual exam. Why that's the case? Because in that case, I can give you the precise schedule of the exam. So you don't need to come here at 9 o'clock if you're expected to discuss your exam at 11. Okay, that's the only reason. Yeah, as I wrote, the tentative schedule will be published when the registration closes. The exams will be in the Bucola Busy Pavilion. I don't know if you ever been there, but it's the actual main buildings of the university. It is like half an hour by feet or 10 minutes by bus if the bus comes. That may happen. It is in the San Lazzaro campus. If you need for directions, I think that if you write in, I put here the directions actually. Look how good I am as a professor. Look. Ta-da. So it's here. If you search